start with today's class. So we are in the last class of the doubt solving on the steel structure subject. So far we have already done with 4 sessions wherein we have solved all the test solutions. Hello Sarina, welcome to the class. Good evening. So today is our last session. So today we will be solving 2 test solutions on the combined topics of important aspects of design of flexural members, plate girders, gantry girders, and industrial buildings. So 2 test solutions we will be doing. So last week test solution we could not cover as we were doing tension and compression member. Hello Krishna, good evening, welcome to the class. So 2 test solutions will be dealing. So one test for 20 marks, the other test for 20 marks. So in this we had 10 questions, and in this we had 5 questions, 10 questions of 1 mark each and 5 questions of 2 marks each. Similarly, another test which was conducted yesterday, same 20 marks, 1 mark and 20. 1 mark question 10 questions and 2 mark question 5 question. Tanveer, hello Tanveer. So good to know that you are watching from Bangladesh. Good evening everyone. So before getting into the class, I would like to tell you if you have already downloaded the Ekeeda app, it's well and good. If you have not downloaded, please download it from the Play Store, or you can just have a look on the live chat comment box. On the top, we have the link given to you, so you can go there and download our app. We have academic courses, professional courses, and competitive exam courses for all the branches of engineering. We normally have the recorded sessions. Hello Manju, welcome to the class. Good evening Manju. So you can take subscriptions. We have different kinds of passes like silver pass, gold pass, platinum pass. So based on what you need, according to your need, you can go and take the subscriptions. So before even taking subscriptions, if you want to know more about the app, you can use gold 11 code. If you use this code, you'll get a complete 3 days uh, free access for the entire courses which are there on the Ekeeda app. Okay, so even in case you will not be able to know anything, you can just drop in a message to us or contact us on this number. We will help you or we will assist you in whatever doubts you have. 9029006464. So we have recorded sessions. Live class will be taken for all the doubts you get in the recorded sessions. We conduct tests. The test solutions also will be conducted, and notes will be provided for all the courses what you take up, right? Individual subject wise course you can take, or as a package the complete course you can take. So please visit the app to know more about it. So to get started with today, we will first proceed with the first test questions. So this test questions which I am solving was conducted last Sunday. We could not cover it in the time slot given to us because we had tension and compression member problems which were very lengthy. So that along with yesterday's test solutions we will be doing today. Total of 30 questions we will be solving. Okay. So let's get started. Whoever knows the solution for the questions can comment in the uh, live chat box. So please type the question number and the answer. Like if you say question number 1, the answer is A, like this you can type it and send it in the chat box so that I will come to know uh, what your answers are. Okay. Shivam, Hindi language, all the languages, all the courses are in English beta. You can have a look once. Okay. Or as I told you, please get in touch with this number. They will help you know all the queries what you have. They will clear it to you. Okay. Or else our technical team is going to comment to your this. As far as I know, we have only English language courses. Okay, chalo. So let's get started. What is the first question saying? Which one of the following? So these all topics, what we will be, or all the questions what we will be dealing are from this subject. So if you want to know the detailed course of steel structure for GATE, these questions are specially for the students who are writing your GATE exam for the year 2022. So you have exactly 3 months left for your preparation. So we have the complete GATE course in our app. So within 3 months, you'll be able to complete it. So every week we will be conducting tests also in order to know how much you have prepared. Say for example, we give you a plan on that you have to study these many topics for this week. So that same topic which is been allotted for you to study, see the recorded classes, the same test will be same topic test will be conducted on Sunday so that you can know your preparation. Okay, so that is the main advantage of using our app. So today's class, as I told you, important aspects of design, design of flexural members, plate girders, gantry girders, and industrial building. The questions will be from these topics only. So we will just be solving the test solutions. For more details on the entire concept, you will have to download the app and go through the course. Okay. So let's get started. Which one of the following cross section is subjected to unsymmetrical bending due to its consumed concentrated dead load? So there is a cross section. Okay, so on a cross section you have what, say for example there is a beam like this, you have dead load. Dead load is normally what? Uniformly distributed load, right? Your dead load is always in the form of your uniformly distributed load on your structure, right? Now this has a certain cross section, so it may be either your I section, right, or it may be the second one they have given is your channel section, the third one is your rectangular hollow section, and the fourth one is your square hollow section. Now out of all this, which one is going to have unsymmetrical bending is what he is asking. So if you can concentrate and exactly see the uh, question. Hello Vlad, welcome to the class. Yes, very good. So it is nothing but the channel section. If you observe, your I section is symmetrical about x-axis as well as symmetrical about y-axis. So this is symmetrical about both x-axis as well as y-y axis. Similarly, your rectangular hollow section also is symmetrical about x-axis axis as well as y-y axis. How do you find symmetry? You just have to cut section like this and have a look. If your geometry is evenly distributed about your axis, then it is known to be symmetrical. So xx as well as yy. So but if you observe this channel section, this is symmetrical about xx axis, right? Whereas when it comes to yy axis, okay, let me put the yy axis in green. So if you put the yy axis, you can see it is unsymmetrical about your yy axis. So the channel section will be the one which will have unsymmetrical bending. Okay, so this is your correct answer. So the same question can be asked as an MSQ for you, giving another unsymmetrical section. So he might give, okay, suppose the options are, say in case I change the options to I section, C section, say L section, and say rectangular section. Okay. Now you tell me, this is an MSQ question, multiple select question. We have already discussed what is a multiple select question. You will have more than one option for a multiple select question in GATE, and you have to give all the answers correctly. Once all the options are correct only, you will get the full marks. But the advantage of attending this question is that there is no negative mark for this question. So in that case, who will tell me what will be the answer? If I change my options like this, what would be my answer now? The answer would be B as well as C. Very good, Vlad. So these both will be my answer when it comes to MSQ. Okay, so they might change a question like this also and give. So you have to be very careful when you're attempting for the GATE exam. Uh, Yoganand, not only C, no, Yogendra, sorry, Yogendra, welcome to the class. It's not only C, no, C section also is unsymmetrical, whereas L section also is unsymmetrical. So both C and L will be your answer. Understood? Yogendra, understood? Okay. Let's get going to the next question. Okay, read out what is the question. Just have a look on what is the question. Question number 2. Please type question number and then the option, or else I will get confused for which question you are answering, because the comments will be a little late. Because this is live streaming, na, the comments will be 10 seconds late than what stream is happening. Okay. Which of the following condition is not a limit state of serviceability? See, please observe carefully. He is telling it is not a limit state of serviceability as per your limit state method of IS 800 2007. So this is the code which you use for all the steel structures, right? So what is the answer for this? So the correct answer for this is the stability. Very good, Vlad. So this is your answer. So in generally in limit state of serviceability, this limit state of serviceability we deal in limit state of serviceability. What do we deal with? We deal with the durability of the structure. Durability of structure. So when it comes to durability, what all should I take care? I normally take care of deflection, vibrations, as well as corrosion, because we are using steel structures, right? So stability is not the criteria. Your deflection, vibration and corrosion all will come under the limit state of serviceability, whereas stability will come under what? The limit state of collapse. Your stability will come under what? Limit state of collapse, because this deals with what? This deals with the safety of structure, right? Whereas the limit state of serviceability will deal with the durability of the structure. Okay, I hope it is clear. So this is a standard you'll have to remember. Okay, chalo, next. Moving on to the next question. So what does the next question has to say? Question number 3. Please type the question number and then the answer. The span of the steel roof truss is 15 meters. So there's a roof truss for which the span is how much? 15 meters. So the self weight of the roof will be, so there's a standard formula for calculating the self weight of the truss. If you know that, you will be able to do it. So what is the self weight of the truss? So generally this is your roof truss. 1 element, 2 element, 3 element, 4 element, 5 element. So this is how your roof truss will look. Or you can also take like this. Okay, but generally this will be how it will look. Done. So anyone with the answer? Anyone knows the answer? They have given the span to be 15 meters. Span L is equal to 15 meters. So generally the self weight of the truss is nothing but span by 3 plus 5 into 10. So this is the standard formula which you should be knowing. Once you know this formula, you can easily calculate. So how much is the span? 15 by 3 plus 5 into 10. So this will be how much? 100 Newton per meter square. Okay, so this, do we have an option? Yes, we have option D. This is your correct answer. Chalo, moving on to the next question. What does it say? Hello Vlad, thank you so much. Chalo, next question. What is this? Question number 4. Which one of the following mechanical property of the steel material, which measure of the amount of deformation of the material, can withstand before breaking it? Okay, so there are different mechanical property for a steel material, right? So the mechanical properties are like elasticity, toughness, durability, hardness. Now each property has something to do with the material. Okay, so he is asking which property will measure the amount of deformation of the material that it can withstand before breaking. So before breaking, to withstand the amount of deformation that is coming into it, the deformation can be deflection, elongation, whatever, right? So what is the property is asking? So the property is what? Durability, or sorry, ductility. Ductility is the property which will help you to deform the resist the deformation of the material before breaking. Okay, so elasticity is what? Elasticity is nothing but the property by which your deformation can be got to zero once the load is removed, right? And what is toughness? Toughness is a resistance against impact. What is hardness? Hardness is the resistance against any scratch. Whereas ductility is what? The property with which you can elongate the material, right? So that is the one which will help you to withstand the deformation before breaking. Understood? Chalo. Moving on to the next question. Question number 5. What does question number 5 say? What will be the maximum value of effective slenderness ratio as per IS 800-2007 for a tension member? See, this is a direct question on the standards of the IS code, right? So, in which a reversal of direct stress occurs due to the loads other than the wind or the seismic forces. Now, according to this, the standard is how much? The standard is 180. Now, if you see the table which is there in the IS code, so the table says serial number. There are 5 categories totally, and the type of member. Okay, so the type of member is, the first one is tension member, prone to reversal of stresses due to the load other than the wind and the earthquake. Reversal of stresses due to the loads other than wind or earthquake. The second one is the members carrying compressive loads. Compressive loads. Due to this compressive load is only due to the dead load and live load. Okay, this is the first one. This is the second one. So for the first one also, the range of slenderness ratio, effective slenderness ratio is 180. For this also it is 180. Similarly, you have the third one. Again, this is related to your compressive load. Now, but this is due to combined wind and earthquake load only. Okay, so the combination. Right, then the fourth one is your compression flanges of beam. Compression flanges of beam. Now these are restrained against your lateral torsional buckling. So these type of structures are not exposed to your torsional buckling. If torsional buckling comes into existence, you cannot take this particular value. So this is 300, here it is 250. And finally, the fifth one is the member which is acting as a tie in a roof truss or in a bracing system. Here, the reversal of stresses due to wind and earthquake force is not considered. Okay. So, this particular value is equal to 350. So, this is a standard what we have in the IS 800 2007. Okay. Now, according to what he has asked in the tension member in which reversal of direct stresses occur due to the load other than the wind or the seismic load. So, for that the answer is 180. Okay. Chalo. Moving on to the next question. What is it? Question number 6. What will be the additional impact load for horizontal force along the rails? So there are rails. He's asking you how much of additional impact load will be given. So this will come under your railway engineering. All right, rails are nothing but the structure on which your train is allowed to move, right? Have any movement. So they are made up of steel sections, right? Many type of material are there, right? They normally are will be looked in this shape. So we have different flat-footed rails, bull-headed rails, double-headed rails. So these all rails are there, right? Now what is he asking? How much of additional impact load should be given for the horizontal force along the rail? Whether it's 10% of the maximum wheel load, 5% of the static wheel loads, 5% of the weight of trolley and the weight lifted, or 10% of the weight of trolley and the weight lifted. Now for this, the correct answer is 5% of the static wheel loads. Again, there are standards for different types of members and your additional load. Okay. Now here also in types of members, I can divide it into your vertical forces transferred to the rails. See, this is important. And then the second one is your horizontal forces. Horizontal forces transferred to the rail. In vertical forces transferred to the rail, I have two categories, right? For your electric overhead cranes and for your hand operated cranes. Okay. In horizontal, we again have same. So suppose I take this as small I take this as capital I. Here also it is small I, that is for electric overhead cranes. Uh, Here this is capital double I. Okay. Here it is for hand operated cranes. And finally, third one is for the horizontal forces along the rails, longitudinal. Okay, now moving on to the standard values. For this, it's 25% of maximum static wheel load. So if the vertical force has to be transferred and you have a electric overhead crane, then the additional load required is how much? 25% of the maximum static wheel load. And if it is a hand operated crane, it is 10% of the maximum static wheel load. That is what he is given in the option A. This is for vertical force. In the question, what is given to us? For horizontal force. Again, in horizontal force, we have different category: hand operated, electric overhead, and horizontal force along the rail. So if you observe, he is telling horizontal force along the rail, right? Now if it is electric overhead cranes, then it will be 10% of the weight of crib and weight lifted on the crane. Crib is nothing but your trolley. Okay, so the trolley, whatever he is telling here, is nothing but your crib. Okay, then the second option for hand operated cranes, it is 5%. Everything remains same, but it is 5%. If you observe, he has given those options also here, right? And the last one is the 5% of the static wheel load. Okay, so the correct answer is what? 5% of the static wheel load. Chalo, let's go on to the next question. So almost many of the questions from the steel structures will come based on the standards. Okay, now as per hmm, as per guidelines for selecting depth of plate girder, what is the ratio of depth to equivalent span of the girder to be taken for highway bridges? So if you're going for highway bridges, what is the depth to equivalent span ratio he is asking? Depth to equivalent span ratio for a girder, especially in your highway bridges. Okay, now for this, the answer is what? Between 1 by 12th to 1 by 18th. So it's a standard which you have to remember. Okay, moving on to the next question. This was question number 6. Question number 7. Let's go on to question number 8. What is this? Intermediate transverse stiffeners are provided. So what is the reason for providing intermediate transverse stiffeners? He is asking. So transfer the load from beam to the support, improve the buckling strength of web, improve the buckling strength of flange, increase the crushing strength of the flange. See, generally transverse, how are transverse stiffeners provided? So if this is your I section, you will provide the transfer stiffness like this. Generally, this is provided in the web portion to increase. See, normally when the load is applied, there is a lot of tendency that if the height of the web is more, they tend to buckle like this. Now, in order to avoid this buckling, we are going to provide what? Your intermediate transverse stiffeners. Okay, so what will be the correct answer? To improve the buckling strength of the web. That is the reason we will be providing your intermediate transverse stiffeners. Okay, so that's your correct answer. Next, moving on to the next question. Question number 9, 1 mark question these are. Okay, which type of beam connection is suitable when shear force to be transferred in the beam is so large that seat angle may fail? Okay, so what is seat angle? In order to connect beam junctions, we provide angle sections at the junctions. So those seat angles will fail. will fail in few conditions whenever the shear force has to be transferred. Okay, so in which type of beam connection, in order to avoid that, which type of beam connection is advised is what is he asking in the question. Which type of beam connection is suitable when shear force to be transferred in the beam is so large that seat angles may fail? So the options are framed connections, unstiffened seated connections, stiffened seated connections, none of these. So in order to strengthen it, what we have to do, a stiffer angle should be provided. Okay, so if the stiffer angle is provided, automatically the strength will increase and the failing will not occur. So the correct answer for this is what? Stiffened seated connection has to be provided. Okay, then moving on to the question number 10. So what does it say? What will be the bending moment of continuous purlin with load intensity W per unit length and L is the length between two adjacent support? So what is it telling? There are two adjacent supports. The length is L. The intensity is W per unit length. Okay. So generally these purlins are simply supported at your truss or any of the rigid frame rafters. So the maximum bending moment will be how much? In this case UDL over entire span, it will be WL square by 8 about each axis, right? About each axis, right? So this is generally this is just a twisted question. For a simple question he is asked you like this. So what will be the, but here be very careful how what he is asking. Suppose if sag rods are provided, they will provide what? Lateral support with respect to your z axis, or bending will act at your transverse supports by your y axis bending. Okay, so requiring the purlin to be treated as your continuous beams. So generally this is the thing, but because purlins are mainly used for the supporting trusses and your rigid frame rafters, we use them as a sag rods. So these, instead of being taken as simply supported beam, they have to be taken as continuous beam. So in case of continuous beam, what will be your maximum bending moment? Maximum bending moment in the adjacent spans, this will be equal to how much? WL square by 10. So what is the correct answer? WL square by 10 is the correct answer. So tricky question, simple question but a tricky question. Make sure you don't get confused. A lot of students tend to just directly put A as the option, right? But it is completely wrong, because purlins generally be considered as your continuous members. Okay, or if not anything, in the question he is given the hint, bending moment for continuous purlin. See here, he has given you the hint. So this hint if you can grasp, then you can easily do it. Okay, chalo. I hope it's clear now, right? So these are all your 10 marks questions. So let us now get into the 2 mark questions of the same test which was conducted. Okay, so the first question for 2 marks. There are total 5 questions for 2 marks. Okay. Ah. Gross flange area of a riveted plate girder is to be designed. So what we have to design? We have to design the flange area of a riveted plate girder, considering a net area as 80% of the gross area. So they have given the area net is 80% of area gross. So if you want to write it, it will be 80 by 100 It will be 4 by 5 of area gross, your net area, right? What else is given? Consider the width of the flange. So he has given the flange width to be how much? 500 mm, while the web plate as, so the web plate, this height is given as how much? 1000 mm, and the thickness is taken as 12 mm. The girder is to resist a bending moment. So he has given you the bending moment that the girder has to resist, which is 4500 kilonewton meter, and the allowable maximum stress, bending stress. So I'll write it as sigma B maximum, that too in tension, is 150 MPa. The given datas are very, very important. Okay. Right now, from where shall I start doing? First, we have to do the section modulus calculation, or required section modulus given by Z E, because we are considering elastic section modulus, not the plastic one, which will be moment by sigma B max. Okay, so how much is the moment? 4500 kilonewton meter it is. So we'll do one thing, we'll do the conversion into Newton and mm. So there will be into 10 power 6. So same thing I have put it here, and this is directly Newton mm, megapascal. So it will be divided by 150. So 30 into 10 power 6 mm cube. So once the required section modulus is obtained, what will be the net moment of inertia? What will be the net moment of inertia? How will you calculate the moment of inertia? I net. Generally, we know that Z is equal to I by Y max. Right. So, if you want I, it will be Z into Y max, or ZE. ZE we got how much? 30 into 10 power 6. How much will be Y max? It will be 1000 by 2. Why? Because we will consider this as the section. Okay. Web section by half. So how much will this come up to? This will come up to 15 into 10 power 9 mm Q. This is what moment of inertia, no? If it is moment of inertia, it will be mm power 4. Right, this is your net moment of inertia. Now, let me take another slide because it won't be sufficient for us. Now, I will calculate just the moment of inertia of the web now. Moment of inertia of web. So IW will be how much? 12 into, because it is rectangular in shape, BD cube by 12. Okay. So BD cube by 12 will give me 10 power 9 mm power 4. So in from this, what will be the net moment of inertia of flange? See, previously whatever I calculated was moment of inertia for the entire section, right? This is for the entire section. Now I just calculated the individual web section. Now if I want a flange, what can I do? I can take for the entire section minus the web section to get the flange moment of inertia, right? So that we got as 15 into 10 power 9. Am I right? Yes. 15 into 10 power 9 minus 10 power 9. So how much are you getting this one to be equal to? Don't get confused. Don't write 15. Many of the students try to say, try to do 10 power 9 minus 10 power 9. One, it will go outside. 15 is remaining. Like that you cannot do. It is how much? 14 into 10 power 9 mm power 4. Now what do I want? IF is equal to AF into Y square. So 14 into 10 power 9 into area of flange we don't know. That is what we have to design, right? Into Y square. Now flange is nothing but 500 whole square. So how much will you get? The net area, net flange area, just simplify it. Net flange area. So if you observe, AF will be 14 into 10 power 9 whole divided by 5 5s are 25 0000. Okay, so this on simplification you will get 56,000 mm square. So finally, what will be the gross flange area? The gross flange area will be 56,000 by 0.8, which is nothing but 70,000 mm square. Why? Because he has given, now we have just in the starting did it. Net area was 4 by 5 times of gross area or 0.8 times of gross area. Is it clear? So this is how you'll have to do. Have they given the options? Yes, here. So here all this, actually if you read the question it's understood. We have to calculate what gross area of flange. Only in one option they have given gross area of flange. Directly you can put this as your option. Okay, you don't have to even calculate this. But it's better to do the complete calculation. Okay, so this one was your question number 1. Moving on to the second 2-mark question. A cantilever steel beam of span 3 meters. So there is a beam of span 3 meters which is carrying a uniformly distributed load of 20 kilonewton per meter. It includes the self weight, so weight of the beam is also included. So the beam comprises of ISLB 200 at 198 Newton per meter, flange as 100 mm into 7.3 mm and web as 5.4. So the flange width is given how much? 100 mm, so I'll take it as flange into 7.5 7.3 sorry 7.3 mm and web thickness is given as 5.4 mm. IXX is given to us as 1696.6 centimeter per 4 and IYY is given as 115.4 centimeter power 4. And in the question he has mentioned cantilever steel beam, so it is simply supported at one end and free on the other end. Now what is he asking us to calculate? First of all, see here, shear stress, bending stress, shear stress, sorry, bearing stress, shear stress and bearing stresses are given in the question. We have to see which of the following are correct. Okay, so basically we have to find the shear stress as well as the bearing stress. Now what is shear stress formula? Tau is nothing but V square by dt. That is what your shear force by shear area. Right, shear force is V square, area is d into TW. Right, similarly we want the, actually this is the bearing stress, bending stress you can take. A lot of the students will get confused. This is actually bending stress you can take. Okay, now if you want the bending stress, what is the formula for bending stress? That is M by IXX into Y. So basically I want V and M. So what is M? M is the maximum bending moment. So for a cantilever beam with UDL over entire span, it is WL square by 2. So W is 20, L is 3 square by 2. So it will be how much? 90 kilonewton meter. And what is the maximum shear force you will get? Shear force is W into L. That's 20 into 3, which is equal to 60 kilonewton. Now you do the substitution. Let me change the color. So here, sorry, this is just V, shear force by shear area. Shear force by shear area. Shear force is how much? 60 into 10 power 3 area depth into thickness. How do you find depth? He is saying it is ISLB 200. So the depth is how much? 200. Thickness is given as 5.4 in the web thickness is given in the question. Okay. So this will give you a value equal to 55.55 Newton per mm square. Do we have shear stress 55? Actually this should be mm square. It's cut. So A, option A is correct. Similarly, let us also, this is a MSQ question. Let me tell you, multiple select question. Okay. Now I'll calculate the bearing stress. M, how much is M? We got 90 into 10 power 6. Why? Because here 1 kilo, here 1 meter, we have to do the conversion. IXX is given as 1696.6. There we have centimeter power 4. So into 10 power 4 we have to do, because centimeter to meter is into 10. Right, into Y value. Y is again how much? Total depth by 2. Right, so this will give you how much? 530.47 Newton per mm square. Do we have a bending stress equal to this in an option? Yes, we have option number D. Right, so the options A and D are correct in this particular case. Understood? Next, moving on to the next question. So this is question number 3. What does it has to say? An I section is built up by welding a 200 mm into 16 mm web plate. So given, it's given in the question here, 200 mm into 16 mm web plate is welded into I section here like this with two flanges. So these are your flanges, both equal flanges are there, right? And this is your web, right? There is a 8 mm fillet they have used here, 8 mm fillet weld. The maximum shearing force which may be allowed if the mean shearing stress in the web and the maximum shearing stress in the weld are not to exceed 100 Newton per mm square in kilo Newton. He want two calculations. One is the mean, no, first one is the maximum shearing force. So let me write it as F max under two conditions. The first condition, when your mean shearing stress in the web should not exceed, and the second one is when the maximum shear stress in weld should not exceed, both should not exceed 100 Newton per mm square. Okay, so how to go about this problem? First of all, try to find the moment of inertia. Okay, so first I will do IZZ. So what we can do? BD cube by 12, capital BD cube by 12 minus small BD cube by 12 we can do. So let me just write it. So IZZ is capital B is how much? This one capital B. Capital D will be this total. Okay, so 150 into 200 plus 12 BD cube by 12 minus uh, 2 times of this area I will take. Okay, only this portion. Okay, now how much is this breadth? In 150, remove the thickness of 16. So 150 minus 16, 134. Again 134 by 2. So 134 by 2 is B. Okay, D is how much? 200 cube by 12. So that side and this side, both the sides I need to remove, right? So how much will we get the answer to be equal to? 51.159 into 10 power 6 mm power 4. Right? Next we have to find what the shear stress at a section passing through the weld. So how is this given? F by IZZ B into AY bar. This is your basic shear stress formula. Right. Now in this case, what is B? B is your effective thickness. Effective thickness, which is nothing but 2 times of throat thickness. So how much is throat thickness given to you in the question? Yes, 8 mm fillet he is telling, no? So 2 into 8 into multiplied by 0.7. This is a standard which you have to remember. So that will be how much? 11.2 mm. Now I have to again calculate AY bar also. See, whatever I need in this question I am trying to calculate. So AY bar is nothing but your moment of area about ZZ. So this will be equal to what? 150 into 12 into 100 plus 6. Okay, so that will be 190800 mm cube. Next, what will be cube? Q will be your allowable shear stress, which is 100 Newton per mm square. Okay, so now imply it on this equation and try to do your calculation. So 100 is equal to F is what we have to calculate, right? CF max or F is what we have to calculate by your IZZ, which is 51.159 into 10 power 6 into B. B is how much? 11.2 into AY. AY is how much? 190800. Right. So on calculation, your F will be equal to 300.304 kilo Newton. So exactly onto how many decimal place he has in the exam, accordingly you please do it. Okay. So that will be your answer. Right. Next, question number 4. So what does question number 4 say? A gantry girder is subjected to a factored moment due to static wheel load of 400 kilonewton meter. So factored movement due to the static wheel load is given to you in the question, which is 400 kilonewton meter by an electrically operated overhead traveling crane. If factored movement due to self weight of the gantry girder is, the factored movement due to self weight of gantry girder is also given, then the design movement of gantry girder due to vertical load is, he is asking what? The design movement of gantry girder due to vertical load. So this is nothing but your total design moment, which is given by the addition of three things. What are those? The moment due to static wheel load, static wheel load plus your impact moment plus the moment due to self weight of girder. Right now, there's a trick here or a standard which you have to remember. So, moment due to static wheel load is given 400 kilonewton meter. Moment due to self weight of the girder is given, which is 20 kilonewton meter. You have to get the impact moment. Your impact moment generally is 0.5% of your static wheel load. Okay, so 0.5 by 100 of 400. Not 0.5%. Either you take 0.5 0.5 or 25%. Let me write 25%. Okay, now it's correct. So how much will this come up to? This will come up to 100 kilonewton meter. If you don't remember this, you will not be able to do the problem correctly. So how much will it be? 400 plus 100 plus 20. So that will be 520 kilonewton. Generally what we do, what we try to do is, we just add both of them and give option A. See, to confuse you, he has given the first option to be 420. Okay, but it is actually what? 520, wherein you have to also consider the impact moment. Understood? Chalo, moving on to the last question of the first test series. A tie member of a roof truss consists of two ISA angle sections, okay, of 100, say this is 100, just randomly I'm putting the lengths, okay. Then 75, and the thickness is how much? 8 mm. The angles are connected on either side of a 10 mm gudget plate by 6 mm sharp fillet weld. So there is a gudget plate which is how much? Like this gudget plate of 10 mm. Here this side and this side your angle section is connected. With the help of what? With the help of weld. What this weld is? 6 mm size sharp fillet weld it is. Okay. So generally this is subjected to a factored pull he is given of 450 kilo Newton. Pull means what? Tension. What will be the minimum total length of the welded connection in mm required to the nearest whole number? The grade of steel also is given to us as Fe 410. Now this factored load will be divided equally into both the angle sections. Right. So first what we have to understand, each angle section will carry how much force? Each angle section carries a factored pull of 450 by 2. So that will be 225 kilo Newton. Now I have to find what? LW, L suffix W. This is what? The total length of the weld required. Okay, so how much or how will you calculate? You take the design strength formula, design strength of weld formula, you assume and try to do it. So what is it? KSLW into FU by root 3 into 1.25. So this design strength is nothing but the strength each angle section can take. So this implies what? 225 into 10 power 3 is equal to K is 0.7 because he has mentioned it is shop weld. S is the size of the weld, he is given 6 mm weld. LW we don't know. FU, so in this particular case, if he is given Fe 410, the ultimate strength will be 410 Newton per mm square, and the yield for this will be equal to 250 Newton per mm square. So here Fu is there. So 410 whole divided by root 3 into 1.25. So you will get the value of LW equal to 282.90 mm. So in order to round it off, So how will you round it off? You'll round it off to the nearest decimal. So this is greater than 5. So 283 mm. Right. Now this is for one single angle. For one single angle. Now there are how many angles? Two angles on either side. So multiply this value by 2 to get your final answer. So how much will we get? 566 mm. So the answer for this directly is what? 566 mm. This is your NAT type of question, that is numerical answer type of question. Okay. I hope you understood. Right, next. So this was one test solution which we went through. Now we'll go through another test solution which we had yesterday. Okay, so starting with again 1 mark questions. What will be the design shear strength of a section in kilonewton of ISMB 300 with thickness of web to be 7.5 mm. So web thickness is given as what? 7.5 mm, and he is using ISMB 300. So the total depth will be 300. Then the flange thickness is 12.4. Width of flange is 140 mm, and the grade of steel is Fe 410. So if grade of steel is Fe 410, your Fu will be 410 Newton per mm square, and your Fy will be equal to 250 Newton per mm square. And what is that we have to find? We have to find the design shear strength. Sorry. So we have to find what? Design shear strength. So how will you get the design shear strength? Standard formula. If you remember or if you recollect, your Vd is equal to Fy by root 3 into 1 divided by gamma m naught into H into Tw. So gamma m naught for either your weld or bolt 1.1. Right, Fy is 250 in this question, by root 3 into 1 divided by 1.1 into the height is how much? The height is nothing but 300 into Tw. This is the web thickness, which is 7.5. It's direct substitution of the values. Only thing is you should be knowing the formula. So this is your answer or for Vd. Again, this is a NAT numerical answer type question. So directly you will have to round it off and give to the correct decimal place as asked in the question. Okay. Next question. Have a look at this question. So what this question has to say, or read out the question. Question number 2. What will be the live load in kilonewton per meter square for design of purlins with 15 degree slope of roof? Assume no axis is provided. Okay. So when theta is greater than 15 degree, your live load will be equal to 0.75 minus 0.02 of theta minus 10. Okay, so this is the standard for the design of live load for the purlins. So it's very simple. You just have to do the calculation. So how much is this? 0.75 minus 0.02, theta is 15 minus 10. So on simplification you will get 0.65 kilonewton per meter square. But this is greater than 0.4 kilonewton per meter square. This is the minimum which you can give. Less than this you cannot give. Okay. So this is anyways greater than 0.4. So how much will be the answer for this? 0.65. Say in case you get the solution as 0.35, you cannot give that because the minimum what we can provide the live load on the purlins is 0.4. Clear? Understood? Okay. Let's go ahead and move on to the next question. Question number 3. What is it? The maximum permissible deflection in mm for a gantry girder of span. So the span is given as 6 meters. He is asking you to find the maximum permissible deflection in mm with an EOT, electric overhead traveler, of crane capacity 200 kilonewton. Now your crane capacity is how much? 200 kilonewton of operation, which is less than your 500 kilonewton. So the deflection limit for gantry girder according to your IS 800 2007, actually I'll write here. Okay, so what is it? The deflection limits of gantry girder for electrically operated overhead traveling is given by span by 750. So is given the span. So make sure you put the span in mm into 10 power 3 mm or 6000 mm by 750. So how much will you get? You will get this as equal to 8 mm. Okay, so that much is the maximum permissible deflection which is allowed. Understood? Moving on to the next question. Question number 4. What does it say? A welded plate girder consists of two flange plates of 350 mm into 16 mm and a web plate of 1000 mm into 6 mm. Requires no stiffener, horizontal stiffener, intermediate vertical stiffener, vertical and horizontal stiffener. Okay, now basically first you try to find the value of lambda. The web thickness divided by, sorry, the web height divided by the web thickness. Okay, so height of web, let me write like this: height of web by thickness of web. So height of web is 1000 and thickness of web is 6. So this is coming how much? 166.67. Now generally we know that 85 is less than, lambda is less than 166.67. So we need only intermediate vertical stiffeners for this particular type of design. Understood? That will be your answer. Right. Moving on to the question number 5. Now what does it say? At a certain location of a plate girder of web size 1000 mm into 10 mm. So the web size is how much? This is 1000 mm into 10 mm. A pair of bearing stiffeners. So these are nothing but what? Your bearing stiffeners. Okay, here and here. This is one bearing stiffener, this is a second bearing stiffener. So he's telling that we are welding this. Okay, the effective area of bearing stiffener is asking to calculate the effective area of the bearing stiffeners. So the bearing area will be equal to how much? 100 into 5, right? One side, another side 100 into 5 plus, these are four sides, no? Four sides welds. So I will take, and everywhere it is 10 mm. So 40 into 10 into 10. So this will give you how much? 5000 mm square. So this is the total bearing area. So for this the answer is how much? 5000. So again this is a NAT type of question. So you have to give it to the correct decimal here, whatever he asks. or rounding off should be done exactly to the perfect point. Again, there's no negative marking for your these type of questions. Okay, now moving on to the next question. So question looks big, but it's very easy and small question. What does it say? The member forces in the principal tie of a butterfly roof truss are as follows. So there's a tie member or a tension member, you can call it as. So what is the tie member? AB, BC and CD, like this. Now the stresses in this is given to you. Due to dead load, the tension are in 26 kilonewton, 18 kilonewton and 8 kilonewton. Due to wind load, the tension are 40 kilonewton, 32 kilonewton and 16 kilonewton. He is asking you to calculate the factored design load for the principal truss. How will you do it? Add all of it and multiply it with the factor of safety. Generally, if no factor of safety is given, how much is the factor of safety? You will assume 1.5. So, what will be the factored design load? Factored design load will be 1.5 of total load. Whatever this load can be because of dead load or it can be because of the wind load. Okay, so it's 1.5 times of 26 plus 40 plus 18 plus 32 plus 8 plus 16. So how much will you get this value to be equal to? 99 kilo Newton. Okay, so option C is your correct answer. Understood? So this one was your question number 7. Now let us move on to the question number 8. So it's a direct question, direct standard question. When a gantry girder of span 15 meters, so the span for the gantry girder is how much? 15 meters or 1500 mm, carries moving load such as charging cars, the deflection should not exceed. How do you calculate? Generally, the vertical deflection according to the IS 800 2007, the vertical deflection of your gantry girder should not exceed how much? L by 600 when it is carrying any moving loads. Okay, so this will be how much? 15000 divided by your 600. So we'll give you a value equal to 25 mm. So he's asked you in the question, he asked you in centimeters. So 2.5 centimeters. Don't be in a hurry to answer in the exam. Why? Because you have to take care of the units properly or else your entire solution will go wrong. Understood? So this was your question number what? Question number 7. Now let us move on to the question number 8. For economical spacing of roof truss, if P, T and R are the cost of trusses, purlins and roofs. So this is what? The cost of your truss. This is what? The cost of your purlin. And this is what? The cost of your roof covering, roof covering respectively. So how should be your truss cost? It should be it equal to cost of the purlin plus cost of roof coverings, or 2 times of purlin plus roof coverings, or purlin plus 3 times of roof coverings, or purlin plus 2 times of roof coverings. Okay, so we have to find out. Understood? Now, let me do the derivation for this, but every time it is going to be this only. Let me give you the answer before doing the derivation. So, the answer for this is what? 2 times of purlins plus roof coverings. Now how did we get this? Now let S be the spacing of the truss, okay, and T be the cost of the truss per unit area, and let P be the cost of purlins again per unit area, and R, as it's already given, cost of the roof coverings per unit area. Now I'll assume X to be the overall cost of the roof system per unit area. So generally we know that the cost is inversely proportional to the spacing of the truss. Right. So if you remove the proportionality symbol, I'll get a constant called as C1. Right. So cost of the truss is inversely proportional to the spacing. So more the spacing, less the cost. Why? Because you will need less number of trusses. Right. Similarly, when you go for the second one, that is the cost of the purlin. This is generally directly proportional to the square of the spacing. So what I can do, when I remove the proportionality symbol, I'll get another constant C2 S square. And finally, when it comes to the roof covering, so this is directly proportional to the spacing. So R will be C3 times of spacing. Now what is the overall cost? Overall cost is the truss cost plus the purlin cost plus the roof covering cost. Now what is truss cost? C1 by S. Purlin cost is what? C2 by S square, and R cost is what? C3 into S. Now we want the overall cost to be minimum, right? So if you want the overall cost to be minimum, the differentiation of this with respect to the spacing should be equal to 0. So if I differentiate this equation with respect to x, no, s, differentiate with respect to s. So what will I get? Dx by ds is equal to minus c1 by s square plus 2c2 s plus c3. Right? Now Now, what I'll do, I'll multiply this whole equation. Okay, this should be equal to 0, right? I'll multiply this whole equation with s. So, what I'll remain with? Minus t1 by s square into s plus 2c2 s into s plus c3 into s. Now, this and this will cancel. Now, if you observe, this is nothing but t, right? This is nothing but p, and this is nothing but your r. So what will you remain with? Minus t plus 2p plus r equal to 0. So send t on the other side. See, t will be equal to 2p plus r. So this is how I get the solution. Okay, I hope you understood. Done. Next, moving on to the very important thing here is this. The spacing of the truss is inversely proportional to the cost of truss. Then purlins, it is inversely proportional to the square of the spacing, and for roof covering directly proportional to the spacing. Okay, next, moving on to the ninth question. Which of the following loads are to be considered in the design of a gantry girder in case of your industrial buildings? Okay, so this is a multiple select question. What all you can consider? You can consider the gravity load, lateral load, and longitudinal load. All are correct answer. You don't consider just the wind load. Okay, wind load is not considered. Next, moving on to the question number 10. In a crane gantry girder, a channel is provided at the top girder. Okay, so there's a crane type of gantry girder. They have provided a channel on the top flange of the girder. Now this accounts for bending in. Now, because of that, what bending will happen? He is asking you horizontal plane bending, vertical plane bending, horizontal and vertical plane bending, or both horizontal and vertical plane bending along with twisting. So, in this case, only horizontal plane bending will take place. Okay, so why? Because the channel which is provided the top, this will normally do what? It will increase your lateral resistance. Resistance against the horizontal surge. That's the reason your bending in horizontal plane will take place. Okay, next. Moving on to the 2-marker questions. Now we have 5 2-mark questions to be solved to wind up the session. Okay, so the question number 1 of the 2-mark. What will be the economical depth of the web of a welded plate girder of span 24 meters? So they have given the span to be equal to 24 meters, right? To carry a total factored load. So total factored load is also given, which is 52 kilonewton per meter. Avoid use of any bearing and intermediate stiffeners. So we should not use any bearings nor any intermediate stiffeners. In such way we have to design the economical depth of the web. Okay, so he has given Fe415. So whenever he says Fe415, your Fu will be equal to 415 Newton per mm square, and your Fy will be equal to 250 Newton per mm square. Anyways, he has given you in the question in the bracket this value also. Now, what will be the maximum bending moment? Maximum bending moment. Like this is factored load, total factored load. If you observe, this is in kilonewton per meter. So this is nothing but they have given in the form of UDL. So it will be WL square by 8. So how much is W? 52 into L is how much? 24 whole square divided by 8. So you will get a value equal to 3744 kilonewton meter. Now we have to avoid, no, stiffeners cannot be provided, bearing cannot be provided. So in order to avoid that, your K should be equal to D by TW less than 67. Right, now the economic depth of web will become what? How will you get this 67? I forgot to mention that. So this depth and this thickness ratio should be less than or equal to 67. Okay, that's the standard, right? Now, what will be the economic depth of web? So, it will be D equal to under root cube root mk by fy. So, cube root is nothing but 1 by 3, no? I'll write like this. Okay, moment is given 3744 into 10 power 6, and K is given as 67 and Fy is given as 250. So you will get 1001.13 mm. Now if you want to round it off to the nearest decimal, 1001 mm is your depth which you have to provide. Okay, so see, point 1001 cannot be provided, no, depth very difficult, so you can go with 1000 mm depth, or you have an answer right here. You have different answers. So the nearest for all of this is what? Hello Monica, welcome to the class, thank you so much. So the nearest or the correct answer for this is going to be how much? It's going to be 1000 mm. Right. Next. Moving on to the next question. That's your second question from 2 marks. What will be the wind pressure at a height of 12 mm for basic wind speed of 47 meters per second. Okay, so they have given the basic wind speed. I'll call the basic wind speed as VB, basic wind speed is given how much? 47 meters per second. What else is given? See, coefficient K1 is given as 1.0. Terrain height and structural size factor is given as 0.92. Topographical factor K3 is given as 1.1, and the fourth one, that is the important factor of cyclonic region, K4 is given as 1.15. What is he asking? He is asking the wind pressure at a height of 12 mm. So generally your pressure is given by 0.6 times of Vz square. Now what is Vz? Vz is your design wind speed. What is the formula for design wind speed? It's K1, K2, K3, K4 into VB. So for the basic wind speed, we have to multiply all these four factors. Then you will get the design wind speed. So how will you do it? So K1 is 1.0, K2 is 0.92, K3 is 1.0, K4 is 1.15 into the wind speed is 47. So 49.726 meters per second. Now put it here, you will get the pressure. It's as simple as that. Okay. So whole square. So on simplification, you will get 1483.6 Newton per mm square. But the answers are here in kilonewton and meter square. So how much will it be? 1.48 kilonewton per meter 1.483 kilonewton per meter square. Okay, which is the nearest answer? So the nearest answer is your option C. Okay, so basically you should be knowing the formula to calculate your pressure, which is 0.6 Vz square, and an important note, which is Vz is multiplication of all the coefficients along with the basic wind speed. Okay. Now moving on to the next question. Question number 3. What will be the design bending strength for a laterally supported beam? So he has given ISMB 300 plastic section. He is asking what design bending strength. Okay, so generally your design bending strength is given by beta B Z P F Y. This comes under plastic design of steel structures. We have already done these particular type of problems in the first and the second class. Okay, it's okay. So here also we will try to do it. Now, if it is plastic section, it will be beta B ZP. If you take it as an elastic section, it becomes 1.2 ZeFy by gamma naught. Okay, so here beta will be equal to 1. Suppose you have a plastic section. Okay, we have to calculate both and do the consideration. Also, one of the important thing here is, because the section is plastic, your V will be less than 0.6 times of VD. Okay, now you do all the substitution. Your MD will be equal to beta B is 1. Your ZP, C is given the plastic and elastic section modulus. So this is your ZP. This is power 3. Okay, this is also power 3, and this is your ZE. So ZP is how much? 651.74 into 10 power 3. Fy, C is given FE 410 grade. This also is given to you in the question. Okay, so FE 410 grade, for FE 410 grade your FU will be 410 and your FY will be 250. These are standards, you will have to remember them. Understood? So Fy is how much? 250 by 1.1. Sigma I am not right, into 10 power 6 because I have to do the conversion into kilonewton meter of the kilonewton meter. Right, less than or equal to 1.2. ZE is how much? 573.6 into 10 power 3 into 250 whole divided by 1.1 into 10 power 6. So how much are we getting? 148.12 kilonewton meter less than equal to 150. Sorry, let me erase this and write it properly. 156.44 kilonewton meter. So what you should do, you should take the least. So what will be the answer? This will be your answer. See, 156.44 also is given, but generally the design bending strength will be the lesser of the two. Understood? Chalo. Fourth question. What will be the web crippling strength in kilonewton for a welded plate girder with width of stiff bearing on the flange is 100 mm. So the width of stiff bearing, generally the notation for this is B1. The thickness of the flange TF, this is given as 100 mm. Thickness of flange is given to us as 14 mm and the thickness of web is given as 16 mm. We have to find the web crippling strength, that too in kilo Newton. So the web crippling strength is given by the notation FW. So if you have to just remember this formula in order to do this. B1 plus 2.5 of thickness of flange into Fy by gamma m naught into thickness of web. So this is a standard formula. Okay, so what will be FW? B1 is 100 plus 2.5 into TF is 14. Fy nothing is given, so consider it to be Fe 410. Okay, so your Fy will be 250 and welded connection 1.1 will be the gamma m naught into the thickness of web, which is equal to 16. Okay, so you'll get this answer in kilonewton because I have done the substitution in such a way, right? So you will get it to be equal to 490.91 kilonewton. So this is a NAT type of question. So correctly to the decimal place, you have to give your answer, right? Moving on to the last question for today. The maximum permissible deflection in mm for a gantry girder spanning over 6 meters. So there's a gantry girder which has a span over 6 meters. So greater than 6 meters it has. He's asking you to calculate the maximum permissible deflection in mm. Now see, this is a very very interesting question. Let me put star marks for this. Important and interesting question. Why is it interesting? First of all, it is multiple select question. So there may be two answers correct, three answers correct, or four answers correct. Right? Now we have to do the calculation for all of them. Only then we can get it. Right? Now first, see is asking. Now this gantry girder is doing some work, either changing car in operation it is taking, or carrying crane with load capacity and with manual operation, or carrying crane with load capacity with electrical operation, right? Whether these values are correct or no, we have to check for each one, right? First I will check for charging car in operating. Now for this it is L by 600. So how much is L? 6000 by 600. So this is giving me 10 mm, right? Is it giving? See, this is not correct. See, here it is given 6 mm. So this is not correct. This is correct. Right. Next, B bit I want to do. What is this B bit? Deflection for, I will take, these are what? What am I trying to calculate? The maximum deflection. Okay. Now this is for maximum deflection, manual operation. So if you're going for manual operation, what is the standard? We have L by 500. So this will be 6000 by 500. So which will give you 12 mm. Do we have it? Do we have it? Yes. See, 12 mm. Manual operation. Okay, load carrying capacity has nothing to do with this. Don't get confused. Okay, or to in order to decide the standards which you have to take, they have given the load carrying capacities. Right, then it is for electrically operated cranes. Now for electrically operated cranes, this is again L by, sorry, not 500, here it is 750. L by 7, is it? L by 750, because the weight it has to take is less than 500, no, 500 kilonewton. That's why L by 750. So how much is L? 6000 by 750. So this will give me a value equal to 8 mm. Is it correct? Yes, 8 mm. Right. So what are the correct options? A, B, C. All are correct answers. Right. So this is about today's session on two test solutions. So in the span of 1 hour 45 minutes, we have solved almost 30 questions, right? So by this class, we have finished the doubt solving sessions on the steel structures subject. So in order, if you want more details on this subject, you can go to the Ekeeda app, download it from the Play Store, or the link is also there in the description box, live chat, right? So also for the fresh users, you can use Gold 11 code so that you get a complete 3 days access for all the courses in our app, be it professional courses or academic courses or your competitive exam courses. All the recorded sessions will be there, notes will be provided, you will be having test every weekend, tests you'll be having, and those test solutions we will be engaging in the live classes, right? And also in our website, we are launching a new complete course on gate for 2023. You can have a look with that. And if you have any queries, you can call us on 902-900-6464 for any queries regarding our app. We will be very happy to assist you. Okay, so please do like, share, and subscribe to our channel if you want the live class updates. So I'll be coming up with some more subject live doubt clearing sessions very soon. The next schedules are not yet given, so once we get it, we'll be having classes, my classes. Okay, but meanwhile there are so many other classes also, live classes that have been conducted on our YouTube channel. So please subscribe, so and hit the bell icon so that you don't miss on any notification. Okay, so I'll see you soon. Bye bye, take care, have a great week ahead.